Welcome to this class. This session, we are going to do two problems on proving that functions are differentiable and evaluating values of the derivatives of functions at specified points. So the problem is to prove that the function given by x cubed minus 12x is differentiable, and to state its derivative and then the derivative at minus 3, 0, 2, and 3. Now, to show that a function is differentiable, we have to show that in the definition of a derivative of a function, then that limit exists. So, solution, we need to show that the limit in the definition of a derivative of a function exists. That is, limit as h approaches 0, f of x plus h minus f of x divided by h exists. So this what you need to show that a given function is differentiable. Now, f of x is given as x cubed minus 12x. That's what we are given in this question, x cubed minus 12x. So this implies that f of x plus h is given by x plus h cubed minus 12 into x plus h, which simplifies to x power 3 plus 3x squared h plus 3x h squared plus h power 3 minus 12x minus 12h. So the limit will be limit as h approaches 0 of x cubed plus 3x squared h plus 3x h squared plus h cubed minus 12x minus 12h. Now minus x power 3, but then this will be plus 12x over h. Now, in this step, x cubed and minus x cubed cancels, minus 12x plus 12x cancels out. So that we have limit as h approaches 0, 3x squared h plus 3x h squared plus h cubed minus 12h divided by h. Since all the terms in the numerator have h, so we factorize out h. So we have h into 3x squared plus 3xh plus h squared minus 12, and then divide by h. Now h and h cancels out, so that we have limit as h approaches 0 of now 3x squared plus 3xh plus h squared minus 12. Now at this point, just do direct substitution. Where there's h, we put 0. So we'll have 3x squared plus 3x times 0 plus 0 squared minus 12. So this will be 0, this term will be 0, so we just have 3x squared minus 12. So hence, since limit as h approaches 0 of f of x plus h minus f of x over h exists, which is equals to 3x squared minus 12, then we conclude that the function given by f of x equals to x cubed minus 12x is differentiable. Actually, for all values of x. Good. And then second part is just now to give this. The first question was now to compute f prime of x. Now from definition, f prime of x is limit as h approaches 0 of f of x plus h minus f of x over h. And because we have already calculated it, then the answer is just 3x squared minus 12, what we have calculated as our limit. So that will be the value. Part 2, we were to evaluate f prime at minus 3. Now this simply means where there's x in this solution, we put minus 3. We have 3 minus 3 squared minus 12. Minus 3 squared is 9. 9 times 3 is 27. 27 minus 12, we get 15. And then next one, f prime at 0. So where there's x, put 0 in the derivative. So 0 minus 12, we get minus 12. Part 4, f prime at 2. So where there's x, we put 2. 2 squared is 4 by 2, 12. So 12 minus 12, we get 0. And lastly, part 5, f prime at 3. So we'll have 3 into 3 squared minus 12. And then this will give us 3 squared is 9 by 3, 27 minus 15 minus 12. That gives us 15. So that's how we solve that problem. And then the second problem of the same kind, problem 2, prove that y given by x raised to power minus 2 is differentiable and calculate y prime. So solution, the same thing. To show that a function is differentiable, then we have to show that the limit given in the definition of derivative exists. So we show that limit as h approaches 0 of f of x plus h minus f of x divided by h exists. Now here, we have y equals to x raised to minus 2, i.e. f of x is x raised to minus 2. So f of x plus h will be given by x plus h raised to minus 2. So this is the same thing as writing 1 over x squared, and this is the same thing as writing 1 over x plus h squared. So limit as h approaches 0 of f of x plus h minus f of x over h will be limit as h approaches 0 of 1 over x plus h squared minus 1 over x squared divided by h. So we call this numerator and then this denominator. So let's simplify the numerator. So numerator is 1 over x plus h squared minus 1 over x squared. So the LCM is x squared into x plus h squared. So this one will be x squared times minus this will be x plus h squared, which will be x squared into x plus h squared. You don't have to simplify this. Minus, we'll get x squared plus 2hx plus h squared. So which will be x squared minus x squared minus 2xh minus h squared divided by x squared into x plus h squared. And you see this cancels out, so that we have negative 2xh minus h squared divided by x squared x plus h squared. So limit h approaches 0 of f of x plus h minus f of x over h will be limit as h approaches 0. Now I can factor out h so that I have h into minus 2x minus h over x squared into x plus h squared, and then this we are dividing by h. This sign means division. This is the numerator, and then we are dividing. So that will be limit as h approaches 0 of h into minus 2x minus h, and then over 2x minus h over x squared into x plus h squared times the reciprocal of this. This is minus 2x. Now h and h cancels out, so that we'll have limit as h approaches 0 of minus 2x minus h divided by x squared into x plus h squared. Now, after that cancellation, direct substitution will work, so that we'll have negative 2x minus 0 over x squared into x plus 0 squared. So this will be minus 2x, and then x squared times x squared, because 0 plus x is just x, and then when you square is x squared. So that will give us minus 2x over x power 4, and which simplifies to minus 2 over x power 3. So which is the same thing as writing minus 2x raised power minus 3. So the limit exists. So since limit as h approaches 0 of f of x plus h minus f of x over h exists, which is minus 2x raised power minus 3, for the function f of x actually for all values x not equals to 0, because when x is 0, then it will be defined. For f of x given by x raised power minus 2, then we conclude that the function f of x equals to x raised power minus 2 is differentiable for all values of x which are not equals to 0, because we are dividing by x power 3. And since f prime of x is the same as y prime, is limit as h approaches 0 of f of x plus h minus f of x over h, then y prime is given by minus 2x raised power minus 3. So that was the value of the limit. So that's how we solve those two problems. Thank you.